Hello to you, all my viewers. Welcome to Geonodes Daily series, where we do something cool in geometry nodes and we try to learn as much as possible while doing it. And of course, to use the least amount of time to achieve those awesome goals. Today, we will tackle this great animation that you see here. And basically, we will learn how to do a bunch of effects. The scrambled effect that you see, the box opening, closing, how to synchronize this animation, and I'm also going to uh, help you take a peek into my workflow and how I do some problem solving. So we will do that by following those 5 steps that you saw in the card just earlier. This will be a geometry nodes video. If you want to see the material stuff, check out the link in the description or the one appearing during the demo. As usual, before starting, I want to give a big thank you to all of you that are supporting this channel by purchasing the projects from Gumroad or by liking the video, subscribing to this channel, putting on some comments that can help me improve the work. All of these ways to help me are much appreciated. So thank you very much. Now let's start with this. Let's do the scrambled letters effect. And for that, of course, we will need to start with the text. So let's take a string to curve, plug this one here, delete the input node that we don't need for now, and punch in the text. So let's do capital scrambled. Okay, awesome. Now that we did that, we want to fill this text. So let's do that. Let's do fill curve and plug it here. So now we have this going on for us. This node will put out the letters one by one in the form of instances, and that's great because this will allow us to affect each letter individually quite easily. And we want to do two effects. We want to move the letters and we also want to rotate them. So we will have these two effects going on here. So let's start with the translation. We will want to have, of course, a controller. Right now, if we play, let's say, with the y-axis, we can push everything up. Let's say like 4 meters for now. And playing with the rotation will give us different effects, basically. So how can we combine this stuff? Well, let's take an utilities map range, plug this one into our translation, but change this one to a vector first. And I'm gonna plug this one into the translation, and let's see, we will want to have a value to control everything. So let's plug this one into the vector here, and we'll have, say, an input from 0 to 1, and for the output we can control where the text starts and where it ends. So let's put everything to 0 again, and let's say we want this to start, like we said, at 4. So basically something like this. Put 1, and we have this control, or basically this is where we end for now. Now let's do a rotation, and for that we can use another map range. Let's turn this back to original, and let's think about what we want. Let's say that we want to rotate the text 3 times between one extreme and the other. This will be in radians, so let's do pi times 2. That could be 360 degrees, or you can write tau. That will be basically the same. and let's say multiply it by 3 to have 3 times this amount. And for the value, let's use the same thing from here. Excellent. So now we have this controller that is doing this, but we have a few problems. First of all, everything is moving at the same time, and that's kind of boring. So let's fix that one. And we want to introduce some randomness. And for that, of course, we will need a random value node. And the way to plug this into our setup is to use a math node. So let's do a control click to move the noodles here. And we will add this input value to this value from here. So as soon as we do this, we can see what is going to happen. If we go to 0, we no longer have the letters at the bottom. We have to go to -1. And the reason for that is that this random node has a value from 0 to 1. So we're basically adding a random value that can be anything between 0 and 1. So if we start to move this, you can see what happens. In order to cancel the random value effect, we have to subtract the value of 1 from here. So now if we have the maximum possible output of 1, 1 plus -1 will give us 0. So we will back at this. But if we go all the way to 1, we will get 1 plus 1, and that will be 2. And this being clamped, that means we will not go higher than this. But if we unclamp it, you can see what is happening here. We will leave it clamped. So this is how you can add the randomizing part to this entire setup. And by the way, if you want to expose this value, let's quickly do that. Let's say we want to do a group input and we want to plug this value here. We can open the end panel, go to the group property, give this one a name, let's say fx control. And in order to make this easy to use, let's do a default of 0 and from minimum 1, 0 to maximum of 1. So now if we go here, we basically pushed this controller outside. So now we have this happening because we basically got back to square one and have a 0 to 1 controller that is not exactly what we want. But we can fix that easily by plugging another map range here. And we can reset this node. And instead of having a value, we can have this input from 0 to 1 that we have here. And for the output, we can have -1 to 1. So now we have this nice controller here. Of course, we can inverse the effect by putting this the other way around. So now when we start at 0, we start in this position and we end up here. Excellent. If we want to control, of course, the input here, where the text ends up or starts up, depending how you want to think about it, we can use this minimum value from the node that we added to control the translation. So we can make something like this, for example. And now we have this controller going like this. So that will be what we need to do in order to get this scrambled effect. But stay tuned because we are just getting started with this. We want to do something else really cool, and that's make this text 3D. And why is this interesting? Because instead of using a solidify modifier from here, so if, for example, if we use the solidify modifier, first of all, we have to turn this into real geometry. That's not a big problem. But as you can see, we get this banding, and even if we shade everything smooth, we still get some problems. Let me see. We get this problem. Now we have to add a bevel modifier to make things look nice, and so on and so forth. So instead of doing this method, we can now use an extrude node, but this comes with also some problems. Again, as you can see, we get a problem with banding, and if we try to fix it, it's even worse. As you can see here, we still don't get nice and smooth shading. So there is another method that I came up on by surfing on Twitter. A method discovered by this artist, Red Jam. And this is what I want to show you, how to do this in a very nice way. So what we will need, let's move this one here. We will need a joint geometry. Okay, so let's put a joint geometry, and there will be a few things that we want to do first. So first of all, we want to take this text and make it nice and smooth, because right now, as you can see, it's a little bit jagged on the edge. And for that, we will use set spline type and set it to NURBS. And now let me take this one out. As you can see, we get a smoother text. So once we did this, what I want to do is use this curve to mesh node, plug it here. And now we want to give the profile thickness for this one. And for that, we will use a line and plug it here. Everything turns to a mess, but we can fix that easily by playing with the Y value. So let's say we will do like 0.1 or something. And now we have the profile, but we also want to have a cap. So let's plug this one into the fill triangle and fill curve and plug this one here. And now we have a top, but if we look at the geometry, we see we don't have a bottom. So let's add a bottom, and for that we can use let's say set position, and I'm gonna show you a problem that we will get into with this. So let's take this fill curve geometry and plug this one here, and now we can control the set position of this by playing with the z value. So in order to make this one nice and procedural, let's say separate or combine xyz vector, and we will have this one to 0.1. So let's use a value for that. Plug this one here, Control C here, Control V here, plug this one here, duplicate this node, plug this value into the Z and put it here. And then of course we have to inverse this value. So that's an easy fix. Switch this one to multiply, -1, and now we kind of have this happening. And as you can see, there is a problem here. The text is not aligning, and if we start to do the scrambling, we see the problem getting worse. As you can see here, everything goes sideways and this is not aligned. So if you get into this problem and you ask yourself what's going on here, it can take a lot of time to figure it out. It took for me when I did it first time. The problem is with rotations, because this is working in world space, and we kind of, as you can see, are messing in the world space with the position of the geometry, so everything gets out of sync the more you change the original position. So how can you fix that? Well, if we look at this, we still have instances working. So let's do a Shift S. That will allow us to change this node and use translate instances instead. And if we do this, and we of course plug this one into the translation, and we use the local space, we kind of see that we still have a problem. So let me cut this one. That was leftover. But as soon as we fix that, we see the text, it's nice, no matter how we move it, because we changed the translation from world space to local space. If we were to uncheck this one, we get that problem again. So this is how this is the way to get a nice smooth text without using the extrude that will require the solidify modifier that will require bevel modifier, or the extrude that also has some problems. Now we have a nice clean text. So time to move to the third point, and do the box. And we also want to do something interesting with this box. Let me put it up, this text. Let's go to 1. We would like to make the box in such a way that when it surrounds the text, if we change the text, the box will accommodate it on both axes. So how can we do this? Well, let's do this. First of all, we will need a box, and if we do the usual suspect, sort of speak, and we use the curve quadrilateral primitive, we will get into some problems. But I'm going to show you that later on. It will get in the problems when we will try to make the opening lead. But for now, let's start with this one and figure it out how we can make this in sync. Okay, we kind of want to make this box here. Be aware of the change in text size, and for that we will use a bounding box node and take it after we did nothing to it. So basically we want the original text from here. So this is our original text, we plug it here, and now we can use this bounding box to get a minimum and maximum out of this. So let's do a vector, separate XYZ, and plug, let's say, the maximum, because this is what we care. And now we have these X and Y values that will control this. But if we plug it here, we see that our box is disappearing. And if we hover over this, we see why. This is giving us a 0, 0, 0 vector. And you might ask yourself why, because this is definitely not 0, 0, 0. And we don't get any error messages. Well, the problem is that we are working with instances, and this node is not going to give us what we want if we work with instances. So let's convert these instances into real geometry, and as soon as we do this, we can see that this is not happening anymore. But we have another problem. The box is not aligned with our text. So what can we do about that? Well, let's fix that. We basically want to offset this box, because now it's centered here, by half of this distance that we have here. So let's do a math, switch this one to divide it by 2, and if we plug this value here and plug this value here, we can see that we don't get what we want. Okay, because there is something else that we need to do. We want to move this box, basically. So let me plug this one here, and I'm gonna keep the width, I'm gonna keep this value, but I'm gonna combine this into a vector and feed it to this offset node. So let's do this, plug it into the offset, and as you can see, now this is aligned, and if we change the text, things will just stay nice. So let's say we put something else here, and no matter what we type here, the box will follow our text. So let's put the original text back. And as you can see, now we have another problem. Our text is not exactly in the box because we changed it after we did this. And I don't actually want to change that fact because I want to be able to position this any way I want in the box. But by playing with these values here. But what I want to do is to be able to make this box bigger or smaller. And if I want to do this, I can do now some more math. So let's do this node, switch it to add and plug this one here. And now we can basically add to the value of this box something to make it exceed the text. And of course, we can duplicate this one, plug it here, and we can use this new value to control the height of the box, as you can see here. But in the case of this one, I don't want it to go below 0. So we will use this information into this offset, the divided value. So if we plug this one here and make sure to do this to make sure that you unplug that unwilling connection. Let me arrange stuff a little bit. So if we take this y value here and then we pass it, we keep the divide here, but we pass this output, this offset to this one, the one that it's responsible for offsetting this, we kind of get this value. So no matter how big we make the box, it will always stay here at the bottom because we fed this offset to this divide node that it's taking care of repositioning the box. So this is how you can make this this box working. But now we get to the part where we want to make the lid, and this will be the problem because we used here this quadrilateral. We could do a mask to move this point here. So let me show you what I'm talking about. I'm gonna do this. Let me duplicate this set position node and put it like, let's say 2 meters here. And let's say we want to open the lid. So I can do something like curve endpoint selection and plug this selection here and decide what point do I want to use. And I want to use this point. So now we have a nice controller for the opening of the box, but it's not actually opening because this part is still attached. So the next step would be to open this curve. So let's say set spline cyclic. And now we have the open box, but we have another problem. This part disappeared. So in order to fix that, you would have to do something before making this happen. We will have to resample this curve. And let's say do a length resampling and get this. And Now you see things are still not working as you wanted. Of course, you can put this resample first and plug it here and set this spline cyclic first here. And now you have this opening, but the mask is not working. So you can increase this value and the mask is sort of working, but you don't get that opening, you just get this linear star. And now you will have to create a gradient that will affect less this point and more this point. So as you can see, things get quite a bit complicated. So let's delete these nodes. It's doable. I kind of did it for other projects, but the principle that you should follow when you do project is keep it simple, because more you nodes you add, more overhead you get in the computation, harder it is to debug and more time it takes. And I got into this problem quite a bit of times when I brute force my way through problems, and that takes also time. So that's a good way to learn. But if you just want to make a simple effect, or you have a complex project, you don't want to make things complicated at every step. You want to find the simplest solution possible. So basically, this is what I want to show you: how to make the lead box opening without that complication that I showed you earlier. So as we saw, going on the curve approach, it's not gonna give us very good results, because we get into all these problems. So if we can't use a spline, what can we use to make a box? Well, the only other option is a mesh primitive. So the next question is, what is the simplest primitive that will give us this result? And the answer is simple. We can use a grid. So let's delete this node and plug a grid here. And first we need only 2 points. And now we have a size X and a size Y, and everything works just great, apart from the fact that we have a face. So how can we get rid of this face? Well, instead of using 1 gazillion nodes, we can use just one node, the delete geometry. And we don't want to delete the points, we want to delete face, and we want to delete only the face. So now we have this profile here. So excellent. But how can we make this one open now? Well, it's a lot easier. We will still need to build a mask, but we will not get into all those problems. So we want to open the lid. So basically, just like in real life, we have to have this separated from our geometry. So do we have a node that can separate geometry? Yes, we do. We have this node here. So let's plug this one here. We will want to separate based on the edge. And now we can build our mask. And a simple mask that will be, we can just take an index. We just know that we have only these vertices here, 1, 2, 3, 4. So that's gonna be easy to make. Let's do a compare. Take this, turn it into an integer, take the index and plug this one here, and let's find our lead. Yep, that's gonna be our lead. We have this one here. As you can see, we have the lead here, and of course this is the rest of our geometry. So we can basically plug it here, and we now know that we can create our set position thing here. If we move this one as, let's say, 2, we see something happening. The line is moving, that's excellent, but it's moving on both ends, and we basically want to move this end and pin this one. So how can we do that? Well, we can do another mask based on the index. So let's do just that. I'm going to plug this one here, and let's see what index we'll have. That's easy because this is a line. It has 1 point, 2 points. So let's see. We can switch this one to equal. Actually, it's going to be easier. Excellent. This I left on greater. If you want to put it on equal, you can do equal and say equal to 3, because this is what we needed, the third edge. If I mute this one, actually, let's cut the mask. You can see this working very nicely. This is the first edge, second edge, third edge, fourth edge. Excellent. And now we can plug this one back. And now we have this nice controller for our lead. Excellent. So now that we did all these nice controllers, let me do a box here for this, plug this one here, and move to the final point. We will add a thickness and solve a problem, and also we will build a UV map. So how can we do this thickness? Well, we have an edge that it's doing what we need here, and let's make things nicer by plugging this one here and plugging this one here and this one here, and this way we have a nice single noodle for our box. And in order to give it a profile, that's when the curve would have come in handy with this curve to mesh node. But if we plug this one here, we see that we have an unsupported type mesh, but we also have a node that is called mesh to curve. So we can plug this one here, and now we get what we want. Now we can build our nice profile. So what do we want for a profile? Well, I'm going to use a line. So let me plug this line here, and we get this ugly mess. But if we change this one and we play with this value, we kind of get our thickness. And now we can decide how we want this lid to open. As you can see, now it's opening weirdly, because we were expecting it to break from here, from this point. So it's just a matter of inversing the position for this one. So let's do minus 0.2, for example. And now we have this nice controller here. Of course, you can expose these values to the node tree, like we did here with this input fx controller. You can expose all these values the same way. I'm not going to do that to save time, but I want to fix two problems here. First of all, we have this uneven thickness, and second of all, we don't have a UV map. So let's fix the UV map first. How can we do that? Well, I did this a couple of times. You can use a capture attribute and plug it on both of these curves. This one that is giving us the shape, and this one that is giving us the thickness. And we have a very nice node called spline parameter that has this factor, which is a value from 0 to 1 on the length of the curve. So you get a 0 to 1 value this way and a 0 to 1 value this way. So this is what we need. Now we can simply combine that into a vector, and now we have an x coordinate and a y coordinates to a UV map. So let's plug this one here and go to our group output, and we can give a name to this. And more importantly, we have to give it a name into the UV output. So let's see UV map, for example. And now we can use this one. If we go to the shader, we can use that here. Well, in order for this to work, of course, we have some materials. We have to add these materials here. So let's do material, set material, plug this one here and choose the blue material, for example. And now if we go to the shader and select our blue material, we can do an input attribute and copy this name here, plug it here, and let's see, for example, if it's working. Let's take a simple noise texture, plug this attribute here, control shift click here with the node wrangler add-on enabled, and now we can see our UV map doing its thing here. So this is how you can do the UV map thing. The second thing that I want to fix is this uneven thickness, and that's given by the way the piece bonding is made. When we add this line, so how can we make it even? Well, there is a simple fix for that, and that is going to mesh. Let's do a split edges, and if we plug it here, we basically have separate pieces here on these edges before we combine them, and they get all that nice even thickness. So that fixes that problem, and also we get the UV map. So let's do a frame for this one and see, we have this finished result here. We started with the text, we made a box that it's controllable, we can move it around, and of course we can move it up and down and make it bigger or smaller, and that's awesome. But there is one more problem to fix, and I'm gonna show you that. I'm going to this set position and put it to 0. We get this happening. This infinite line is growing, and that's not what we want. We want this line to stay put. So how can we do that? Well, I'm going to show you that now. Instead of doing this, we will use the position, and instead of moving the points, we will rotate them. So let's go to position. We'll have this vector rotate. That will need a reference, and that reference will be the position. So let's plug the position here. And now by playing with this angle, we can open the lid and the size stays nice. But we have a problem now that I want to fix. This is not closing nicely shut. So how can we fix that? How can we fix the lid length? Well, in order to do that, we kind of have to have access to this information from here, this curve line thickness. So let's do a vector, combine XYZ, copy this value, plug it into the X, and put this one here, and actually expose this value so we can use it in two places. I'm gonna put this one here, plug this one here, and now we will do something here. We will add something to this position here. So let me do this. GX, get some space here, move this one, and we want to add something to this position here. So vector math, it's an add, and now if we play with this value, we can close the lid on top of rotating it. And as you can see, we need this 0.2, meaning the inverse of this value. So we can do utilities, math, take this value from here. We can do either a multiply add or an absolute. So let's do multiply -1 to invert this value. And of course, we will need a vector combine x, y, z to plug here and plug this one to the x. So now no matter how much we play with the thickness, we will have this nicely closed. And of course, playing with this angle, it's going to open the lid, and the lid is going to act more naturally, as you can see. It's going to get smaller, but that's not a problem for this effect. Important is that when we end up with this one closed. As a problem solving for you, if you like it, you can find out how you can make this one keep its length. It's actually a very interesting math involved. So if you figure this one out, kudos to you. You did a good job. But I'm going to leave it like this. I'm also now going to expose all those values. But in the project file that I put on Gumroad, you will have everything nicely exposed, so you can play with all the settings, like I'm gonna show you in a moment. So that would be the cleanup node tree, and as you can see here, we had all the values exposed. You can control the text thickness nicely from here, and you can control where the text starts and ends, as you can see here. So that's nice. You can also control the where the start text ends up, like I said. So that's also nice. And you have this box stretching exposed, and the height exposed. So that's also nice. And the thickness, you can play with that and get some nice results as well. And of course, like I said, we can control the lid closing and opening. The only thing that I didn't fix was this lid changing the length, but that's because I don't think it's a problem for this effect. So here you go. You will find all of this in the project file. And until the next video, I want to say thank you for watching. I really hope you enjoyed this video and you found the tips and tricks that I put inside useful to you. I try to show you how you can do some problem solving, how you can pass some blocks that you will find in your project. And with that in mind, happy